Hi, I'm Anthony Brinkley, the coordinator of the John Paul Theater at Phoenix College. Today I'll be walking you through the process of creating a small piece of scenery, a sign, starting with its digital design, then on to cutting it out of MDF, medium density fiberboard, on our state-of-the-art CNC router, and finally finishing it off with a faux rusted metal paint treatment. Spoiler alert, here's the finished product. Stay tuned to see how it came to be. This scenic piece was meant to be an old rusted metal sign that would hang below a ranch headgate. In this case, the fictitious Clarkson Ranch. Here's one of my research images so you can see what I'm talking about. From the design plates that our scenic designer gave me for the headgate, I decided this sign should be about 10 inches tall by 5 foot 8 inches long. My first step was to set up a blank document in Photoshop. Since it was just a simple black and white image that wouldn't end up as a monstrously huge file, I went ahead and set it up at full-scale size to make things easy on myself. After doing quite a bit of visual research, I zeroed in on what I wanted for the sign. The name of the ranch, flanked on both sides with the ranch's brand. I had to round up dozens of different possible fonts before I had a yippee-ki-yay moment where I found the font. I'm sorry, that's really bad jokes. The font is called Council OT. After using the Select All feature, I was able to use the alignment tools to center my text nice and easy on the workspace. And then I rasterized the font, which means to convert it from a vector-based form into pixels, so I could edit it with some careful erasing, and it ended up looking like a stenciled version of the font. This is so as not to have the inner parts of the letters fall out when I cut them into the MDF. So it started out looking one way and ended up looking a little bit different. It's subtle, but very important unless you want the letters falling apart. As for the brand, I looked through a ton of cattle brands to get some inspiration, and I came up with this. Now, this design would have worked as an actual metal branding iron, but like the text had to be modified so as not to have the inner parts fall out. I laid everything out in the document until it looked pretty good, properly balanced. Now, I was the projection designer for this show, reporting to the scenic designer and, of course, the director. I wanted to be able to give them a good idea of how this sign would look mounted under the headgate and with all of the projections. So I put together a virtual model using SketchUp Pro, a 3D design program to have them sign off on the design. First, I built the headgate, then the projection panels with the frame, the white brick on the bottom, and the rear projection screens in the frame on the top. There were 7 panels altogether, and they were reconfigurable for every scene. Then I attached my projection images to the screen, the found and cropped central image, as well as the 2 side images that I had created. Lastly, I built and hung my virtual sign. After sharing this with the director and the scenic designer, I got a thumbs up for the sign. For the practical part of this demonstration, I decided to go small, as to be able to make use of some scrap MDF laying around the shop. So I'm cutting and painting only the CR, brand, part of the sign. And now we're ready to move from the realm of digital design into the realm of sawdust. So, let's head on over to the scene shop here at Phoenix College. We'll take a look at one of the outstanding pieces of technology that we have that is something that you're not going to find everywhere, a CNC router. As you can see, our technical director has been hard at work here in the cemetery. The shop. CNC stands for Computer Numerical Control, and a CNC router is a machine with a high-speed cutter that can be programmed to precisely and repeatably cut 2D and 3D designs to specifications within thousandths of an inch, from materials as diverse as foam, plastic, wood, metal, and more. Let's fire this thing up and have some fun. The first thing I need to do is open up the ShopBot Control software and initiate the spindle warm-up routine. This gets the bearings properly warmed up to prevent them from wearing out earlier than they should. Now I'm going to remove the dust collection system from the router, starting with the shroud, so the camera can actually see what's going on with the cutting head. The next step is to zero out the z-axis, which is the vertical axis in a three-dimensional Cartesian coordinate system. This is the z-axis touch plate, which sits flat on the machine bed. And this is the clip that attaches to the collet nut on the spindle. When the cutting head gently hits the touch plate, an electrical circuit is completed, which instantly stops the descent of the spindle. On the first go, it comes down relatively quickly. On the second, it comes down much more slowly, so as to increase accuracy. When this procedure is complete, the computer knows exactly how far the cutting head can descend before reaching the machine bed. I'm using a relatively small bit of 1/4-inch MDF scrap already painted black on one side, which will show the action of the cutting head nicely. I'm using Irwin squeeze clamps, which work great as long as you are 100% confident in your setup, so as not to run the cutter into the clamps. Yikes! Other options are screwing into the machine bed, which is a little destructive, or using double-sided tape, or masking tape with superglue, which is a technique I quite like, or buying a ridiculously expensive suction table setup, which is like an air hockey table but in reverse. It's important to make sure the workpiece stays put and stays flat on the bed. I do a quick blend of eyeballing and measuring to determine the point I want the router to center itself on. I put a little bit of blue masking tape on my mark so it can be seen by the camera, and then I move the cutting head into place until it is directly above the mark. At this point, I tell the computer that this is where I want to anchor the cutter, also known as home, the 0, 0 Cartesian coordinates for X and Y. Next, I crack open VCarve Pro, a great piece of software. I create a new file and enter the job setup info. I'm working single-sided, not flipping over my workpiece. Under Job Size, I set up the width, X, height, Y, and thickness, Z, that I want my virtual workspace to be. Depending on the job, it may or may not be the same size as the piece of wood you are actually cutting. I tell it that I've zeroed off the machine bed as opposed to the material surface, and that my XY datum position, my anchor, is the center point as opposed to any of the other corners. I leave modeling, resolution, and appearance as is, because it works just fine. I import the graphic that I want to use, my CR brand. I select it, Then grab it by the center point and move it to the center of the workspace where it snaps into place. Another way to do this is to use the alignment tool, which automatically centers it for me. I need to resize the graphic. 11 inches in width will fit very nicely on the scrap MDF I'm working with. I'm careful to make sure that the link XY is checked, as that will make sure everything stays proportional. The next action is to turn the image into machinable vectors. We do this with the Trace Bitmap tool. I select the image and then click Trace Bitmap. It's a black and white graphic, so I can just leave that as is. I want the corner fit reasonably tight, but enough looseness that the curves flow nicely, so I'll go with the default. I don't really have any stray pixels in this image, so the noise filter is irrelevant and I'll leave it at default. I want the bitmap faded out as much as possible for visibility, and I want the vectors grouped. The preview looks good, so I click Apply and Close. At this point, I'm ready to click over from the drawing side to the toolpaths side. I select the CR brand vectors, which then become dashed lines. Then I click Set under Material Setup to double check that I'm happy with it. I ignore Model Position in Material, as that is for placing 3D models within a thickness of material. The Rapid Z gaps above the material, which makes sure I have safe clearance above the material as the cutter moves, looks good. And Home is set for 0, 0. All is well. Next, I select Profile Toolpaths. I want a start depth of 0, which will be the top of my 1/4 inch MDF, and a cut depth of a 1/4 inch to get clean through it without cutting into the machine bed. For the tool select, I choose a 1/4 inch diameter straight side router bit. It's an end mill, which means it's flat across the bottom as opposed to a ball nose, which is rounded. The diameter is 0.25, a 1/4 inch. The pass depth, or how deep it will cut on each pass, is set for 1/2 of the diameter, 0.125, or 1/8 of an inch. I could go deeper, but 1/2 the diameter is a safe bet to keep the bits from being overstressed and possibly breaking. The step over is a non-factor in this simple cutting I'll be doing, so I just leave it at the default. The max spindle speed is 18,000 RPM, but I'm going to play it safe and go slower with both the RPMs and the feed rate, which is how many inches per second the cutting head moves through the material. The plunge rate, or how fast it descends into the material when it starts to cut, is a modest 0.5 inches per second. Tool number doesn't matter as we don't have an automatic tool changer. I hit Apply and we move on. Under Machine Vectors, I choose Inside Left because I want the cutting head to operate inside of the lines, and I choose Climb for the direction, which tends to be a cleaner cut and extends the life of the cutter, but also tends to want to lift the material up away from the machine bed, but it's firmly secured, so no worries. No allowance offset, no separating the last pass, but I do want tabs. Tabs are small bits of material that will remain uncut, so they can hold things in place. There's a few different approaches to adding tabs. A constant number makes the same number of tabs for each section, which won't cut it for this project as my sections are very different in size. Constant distance means that it will put a tab every X number of inches. I start with every 8 inches. Not enough. So I drop it to every 6 inches and increase the minimum number of tabs per section to 3. Better, but I'm not liking the distribution. So I uncheck the starting the first tab where the machine starts. I'm still not satisfied, so I drop the distance to 5 inches. Bingo. Now I just need to manually tweak the location of a few of the tabs to make them easier to deal with afterwards. It's good not to have more tabs than you need, especially in hard-to-reach nooks and crannies, because they all have to be cut and filed smooth for the final product. I select to add ramps to the toolpath. This makes it less stressful for the router bit to get into the wood. There's a few options, but I like the zigzag over the course of half an inch distance. I name this toolpath CR Brand and hit Calculate, which runs the toolpath simulation. I reset the preview and slow down the speed so I can see it better. I'm showing the tabs with the cursor so you can see those. Then I pointed at the extra material that those tabs are holding in place so the cutter doesn't fling them across the room at high speed, which is not fun. The preview indicates all is well, so I select Save Toolpath, which takes everything I've done in VCarve Pro and translates it into a programming language known as G-code to export to the ShopBot control software, telling the motors where to move, how fast to move, and what path to follow. As soon as I click Save, it opens automatically in the ShopBot software. I click Open and we are ready to start cutting. I click Start, then OK to fire up the spindle. At this point, the cursor moves automatically to the flashing stop box and won't allow me to move it anywhere else for the duration of the cutting operation. This is for safety's sake, so you can't click anywhere but stop in an emergency. There's also a physical stop button on the machine. Now, after all of that work, we finally get to the fun part, making a mess. Like I mentioned, I have taken off the dust collection system, so I periodically have to do a little vacuuming so you can better see the cutting head doing its thing. Occasionally, you can see the cutter briefly stop, lift up, move forward, and then set back down again. Those are the tabs being created. I went back into the VCarve Pro software and repeated the same procedures to cut the rectangle as I did for the CR brand. I don't know which is more satisfying, watching the CNC router cut or watching all that dust get vacuumed up. It looks great, and I'm ready to take off the clamps and remove the one screw I sank where it was bubbling up a bit. I could snap all of the pieces free from their tabs, but I'd rather use a chisel and have clean cuts, so that's what's next. I grab a scrap of MDF to put under the piece while I use the chisel and hammer to cut through the tabs cleanly. It only takes a tap or two. After I've cut through the tabs, I do a little cleanup with a rasp. Turns out I really enjoy the sound of rasping speeded up. I am easily amused. Here's a close-up piece I remove so you can see the tabs. Finally, we are ready to start the faux rusted metal paint treatment. The first step is to spray on a solid base coat of orange. This is Rust-Oleum Rustic Orange, but any shade of orange works quite well. After getting a good coat down, I'll let it dry for a bit. It's not like we're painting a piece of furniture or a motorcycle and need to follow exacting manufacturer dry times, but still, a little dry time between coatings is a good thing if you can spare the time. It's been an hour or two now, and I'm back to lay down a fairly heavy coat of 3M's Super 77 spray adhesive. I'm not wanting to stick anything to the sign, but rather in this case, the Super 77 simply gives a nice bit of texture to the surface of the sign, which makes it look rough and pitted. That's what rust causes to happen to the surface of metal, as the oxidation eats away at it. Don't worry if some blobs and gobs come out. That's actually not a bad thing for the look of this particular application. I'm going to let this dry for about half an hour before the next step. By the way, you might want to wear a pair of latex gloves when you do this, otherwise you end up with a very sticky trigger finger. Ugh. All right, now we're going to hit it with a lightish, slightly uneven coat of flat black spray paint. Don't worry about being smooth. Use random patterns of spraying, get some thicker areas, some lighter areas, and leave a bit of orange bleeding through. These light coats don't need a whole lot of dry time. Now I'm going to give the piece a light dusting of that same orange color. A dusting is considerably lighter than a light coat. Try to keep the nozzle maybe 18 to 20 inches away from the piece. I also want to keep this spray pattern random. It's starting to look a little bit like it's supposed to, but I want there to be some spots and streaks of rust. To achieve this, I mixed up some orange, brown, and red acrylic paint into a nice ochre color, and then I thinned it with water to the consistency of 2% milk. I wanted to try spritzing this onto the sign rather than brushing it on to see how that looked. After I've let it run and then dry for just a couple minutes, I'm going to spray it with some water, just enough to make it run a bit more and soften up any hard lines. After a couple minutes of dry time, I spritz it with water from a very anemic sprayer. I kind of like it, but I think maybe I didn't let the ochre dry enough because it quickly becomes a little too thinned out. I dip an already moistened small chip brush into the ochre to add a little more rust to the scene, and then just a couple of water spritzes to make it run. In case you can't tell, I'm kind of doing some on-camera experimentation here. Now I'm just going to chill for the next 5 or 10 minutes and let it drip dry. Hey, funny story. There was another little step that just happened and you missed it because, you had to go and take a snack break. No, it's because the SD card ran out. I hit record, I thought I was good, I started painting stuff, and when I came back to look at the footage, it only recorded like 10 seconds. Seriously, man. Anyways, I just added a little more of the ochre rust drippings by brush and let it drizzle down in more pronounced streaks. The last step I'm going to do is hit it with a satin clear coat. I'm using Rust-Oleum Satin Clear enamel, but most any satin or matte clear will work to seal it up and give it a touch more depth visually. Whoa, Rust-Oleum Photobomb. Here I'm spraying on a light coat of the clear and calling it good. I'll let that set up and dry for a bit and then come back and take a closer look. Here's the finished product after the clear has had 15 or 20 minutes to dry. Ta-da! Rusty metal sign. I'll give you a few different angles. Make sure to get my good side, says the rust. Does rust have a bad side? I don't know. When I get in real tight on it here in a second, you can see that nice texture from the Super 77 and some nice drippy looking rust streaks from the ochre rust. Overall, I think it turned out pretty well. And by the way, I love this CR brand. Makes me want to start a ranch or something. Well, thank you very much for joining me today for this little demonstration. I hope it was at least mildly interesting for you. And it's a very small example of some of the cool, interesting stuff that we do here in the theater program at the John Paul Theater of Phoenix College. Hopefully you'll join us for a tour or a show or a degree. That'd be good too. And ciao for now.